Hello and welcome to Mr. O'Neill's Algebra 1 class. This is our first dedicated video to Algebra 1. So while we're doing this, we're going to also discuss why we're writing certain things in certain areas. So of course our title will be Algebra 1. And this is section 1.1. Algebra 1 tells us the course. The section tells us that we're looking at what section. The first number in our section, the 1, represents chapter 1. The second number, 0.1, represents the first part of chapter 1. So this is Algebra 1, section 1.1. Its title is called Variables and Expressions. So we're going to write that down. Variables and Expressions. Now, since we're going to be talking about variables and expressions, it would help a lot to know what a variable is and what an expression is. Because in mathematics, if you do not know your definitions, if you don't know what you're talking about, you really can't get anywhere. So we got to know our definitions. The first definition that we're going to go over is variable. And variables are letters or symbols used to represent a value that can change. So if we're looking at things and we run into something that can change, so an example of things that change is how fast your car is going. You're not always going 150 down the highway, thank goodness. So a variable is a letter or symbol used to represent a value that can change. One of the most common variables that we see is the letter X. Of course, this comes from the olden days when there were pirates going around the Caribbean searching for hidden treasure, and they would have a treasure map. And in their treasure map, they would have a picture, probably something that looks like Alaska, because I love Alaska. And then they would have a big X, because X marks the spot. So the big X would change locations, and so the X was a variable. Other very common variables are the letters Y and Z, and of course, Mr. O'Neill's personal favorite, the smiley face, because we really do need to see more smiley faces out there, especially when it comes to math. After variables is the next definition, the next word, which is constants. And constants are values that do not change. A good example of a constant, which will forever remain constant, it doesn't change ever, would be something like the number 2. Because 2 doesn't change. It might become 3 if you add 1 to it, but on its own, it's going to forever remain 2. Another example of a constant would be the number 4. Again, 4 doesn't change, it just remains 4. Another really common constant is 24, because it is an awesome number that represents how many hours you have in a day. So constants are values that don't change. Next up, we need to know what expressions are. There are two types of expressions. There are numerical expressions, and then there are algebraic. So we'll start with the first one. Numerical expressions are expressions that contain only constants. So expressions that contain only constants. So these are the things that we're used to seeing in mathematics. We're used to seeing things like 2 plus 2, because 2 plus 2 has two constants in it. It's a numerical expression. 5 times 6 is another numerical expression. And 24 divided by 8 would be another numerical expression. All of these contain only operations and constants. So what do you think an algebraic expression is? Well, an algebraic expression, and by the way, this is what our class is named after, is the algebraic expressions. That's why it's called algebra. And algebraic expressions are expressions that contain variables. So would this be an algebraic expression? Yes. Just plain old x is an algebraic expression because it contains a variable. It doesn't matter that there's nothing else there. It just has a variable. And so x by itself is an algebraic expression. Another one would be something like x plus 2. Yes, it has a constant in it, and it has an operation, but because it has a variable, it automatically becomes an algebraic expression. How about 5 times y? Again, that's an algebraic expression because it contains a variable. How about z divided by 8? Again, that would be an algebraic expression because it has a variable. So that's it for the definitions and actually for the majority of the concepts in this lesson. There's only one concept left, and that is the word evaluate. To evaluate, if I can spell it correctly, evaluate. To evaluate an expression is to find its value. To evaluate an algebraic expression, substitute numbers for the variables in the expression and simplify the expression as much as possible. So an example of how to evaluate is to what I call plug and chug. You plug in the numbers that you are told to, and then you chug away. You do the operations. You add, you subtract, you multiply, you divide. So an example of evaluate would be something like 2 plus 2. Well, what is 2 plus 2? If you evaluate it, you get 4. What about 4 times 5? Well, if you evaluate 4 times 5, you get 20. What about 24 divided by 8? Well, if you evaluate it, you get 3. So each of these is an example of a numerical expression being evaluated. Now, what about an algebraic expression? So let's take a look at that. So to do that, first we're going to make our little T-chart, just like we learned in our previous video. And on this T-chart, we have the left-hand side represents all of the things that we're doing, and the one on the right represents the justification or explanation of what's happening. So on the left, we'll say let x plus y be an algebraic expression. Where x is equal to 5 and y is equal to 4. And then we would say evaluate x plus y. Excuse me. Well, to evaluate means to plug and chug. So we would evaluate by plugging in 5 for x and then 4 for y. And then we would simplify as much as possible afterwards. 5 plus 4 is 9. So for my justification on the side, I would say sub 5 for x and 4 for y, then perform operations. And we will get into more examples in our next video. Good luck and have fun.